Hello, everybody. Um, Thank you all for helping me come to talk to you all tonight. Thanks for VLA for putting up with me the past couple of years. We've worked together on all of this talk. Well, I'm excited to share it with you all. So before I get into what Flexport does and how we do machine learning, data, and AI, I just want to talk about my team and a little bit about my background, okay? So I own all core platforms at Flexport: data, machine learning, AI, streaming, edge, everything. It's pretty cool, pretty big, and Metaflow is sort of a foundational part for linking the parts together, and that's what we're going to talk about today. So a little bit about me. Today's going to be a little less technical of a talk. We're going to be talking about org structures, how you have to think end to end about the data flow in your systems to be able to make any real insights possible. And I got to this place, I guess, a little differently. So my background is I'm a researcher. I did work in high performance computing, large scale optimization, deep learning a long time ago. I was a really bad researcher. I didn't like writing papers. I just like solving problems. Things were hard back then. We had to be across the whole stack, from the networking to the compiler. We had to manage all the compute ourselves. I mean, I remember in a fit of desperation, I like compiled Mesos from C on from Berkeley just to try to get something that was easier than managing all these nodes. Around the same time, so fast forward about 10 years, in 2016, the same time that Metaflow was being sort of built at Netflix, I was at the Allen Institute for Artificial Intelligence. We're doing, and we still are doing, cutting edge research in deep learning. And at the time, we were building what became one of the first large language models. It's called Elmo. We were looking around and say, how do we help train these systems? Our researchers need to do reproducible research. They do it easy, and GPUs are really complicated. And so we built, one of the first true training platforms. All we did is training. If you squint your eyes a lot, it looks almost identical to Metaflow. The only difference is that you had a Python first UI, whereas we focused a little bit more on containers. It turns out that when we looked to spin this out as a company back then, no one thought machine learning training was important. I guess look around today, right? And finally, and we'll talk about this in a minute, when I first joined Convoy a few years ago, which was then acquired over to Flexport, I learned that I was owning a team that had a unique structure. I own both the data and machine learning platform teams. As I've talked to all of our partners, the VLA, to other companies, this is a little different. That meant that we saw some of our problems a little differently. We saw similarities where other people did not. And so let's get into it. So Flexport owns end-to-end supply chain all on one platform. We get things from the factory floor all the way to your customer door, and it's pretty awesome. Convoy is within Flexport, and it's a marketplace for trucking. We're world-class at how we take and work with smaller truck companies, 2-3 trucks each, and then in aggregate can make them as powerful as the largest. Today's talks that focus on the Convoy side is the side I'm a little more familiar with. We have across our platform multiple ML and AI systems. We have deep learning-based cost prediction models. We have relevance, scheduling, all the things you would expect. In our space, because we work with these smaller carriers, fraud, risk, and compliance is critical. We've invested a lot into this space. And well, I'll give some demos in a minute, finally. And then finally, the classic analytics space. However, in our analytics space, we're getting more and more pushes to be faster. We can't move at the speed of data pipelines. I won't be talking about it today, but happy to talk about it later as well. So fraud is one of the biggest things in trucking. People want to go steal stuff, and it's really hard, right? We have to prevent it. So this is a weird chart because there's 2 axes on the left and right. But these are sort of the industry events. Fraud, stolen trucks per quarter. The red line's Convoy. We've invested a lot into this fraud space because we have to. These solutions mix first-party data, third-party data, machine learning models, deep learning models, and network analysis, okay? As you see back there was a large fraud ring many years ago, and we were actually able to get out ahead of it because we started seeing the behavioral and network effects within our carrier base. And we were able to work with our partners and other logistics companies to go solve it. So now we get to a little bit more abstract stuff. What I hear here is basically a list of teams, groups that have to work together to truly understand end-to-end machine learning. These teams don't involve my teams. These aren't the infrastructure people, this is the builders' personas. So my question here is like, for people here, how many orgs do these groups sit in your organization? How many different groups? I think at ours, it's like, I own 3 of the 4 infrastructure teams that support this, which I think is pretty unique. But they're all over the place, right? Some are in finance, some are in integrations group, some are in the BI team, some are in the science team. It's all over. They all have different backgrounds, different histories, and traditionally haven't really worked together. And so they'll use different words for the same thing and have different compatible solutions for the same type of problem. But they don't really talk about it. So, of all the fake laws, Conway's law is one of the ones I'll go with today. Your systems match the org structure they're built in, right? So if the data team and the machine learning team have never talked, their solutions are going to be different, right? How do they work together? When you see this, what you'll then see is that there's sort of mutually compatible technologies. And I just threw Kafka in the middle because it's always in the middle of every data platform infrastructure space. So let's just put it there. Okay, somebody has to own it. So looking on the left and looking on the right, what you'll see is like on the data side, they've sort of have Airflow and Dagster and Snowflake and Spark and dbt. They are really good at doing data orchestration. They're pretty easy to use. On the right, you'll see, Metaflow, Kubeflow, Starflow. There's the whole real-time stuff with Feast and Tecton, et cetera, et cetera. And they're pretty easy to use if you're a scientist. When you think about the data side, though, the data team can use the right side, but the right side is really hard to use the left side. It's hard to iterate quickly if you're using one of the classic data orchestrators. So we use Metaflow to bridge these domains, and we're going to talk about how we do this now. On the left, you have Airflow, Dagster, Snowflake, Spark. On the right, you have Metaflow, other things. We're going to read Metaflow, okay? We want to have a system where builders work in this technology they want to have. So our data team works on dbt, our science team works in Metaflow, and they all work together. The way we do this is first, we have to get dbt to work in Metaflow, okay? It's a little bit of work to get that done. We're going to show how we do it. We have one flow spec for every simple DAG we have that has a branch, and we have deployment time configuration. We really work closely with the teams to help make this work. We've integrated metrics into the thing. We have some dbt-specific cards because we want to see what works, what doesn't. And we want YAML-based configuration. Let's look at an example here, okay? This code is useful. It's not going to compile on your computer, though, okay? I want it to fit on a screen. First thing we want a decorator so that we can actually say, hey, for this DAG, we want it to run on a schedule or on an event or when another DAG finishes. So we built some custom decorators for this. Okay? Then it actually turns out it's pretty simple. This is the whole flow for a generic dbt compiler or for a DAG runner. There's some code here for the execute dbt DAG flow. How that works is you run dbt, you get the manifest, you then parse that little thing that turn into a data pipeline. But we could effectively take for every project, turn into a DAG. Here's the flow steps that go. They get created sort of automatically, and then it goes. And here's how they run. Our builders are, they're BIEs, they're analysts. We want them to think in terms of text. Things are easy to understand. This is an example of the 3 DAGs needed to run to support the fraud cases I had. DAG name, here's the owner, how is it triggered? And then you tell us which models you want to run. There's a selection function, so there's like a little DBT macro that you can write that says, hey, this is where it goes. We just pull that out for you. Here's an example of the DBT card we built. If we have UI people want to partner with us, we'd love to make this prettier, more useful. But see, it looks, it runs all the stuff. It tells the success. You have the runtime. You see all the different tests it runs. You make sure they pass. If they don't pass, they'll send an alert off with the integrated metrics off the Datadog and then PagerDuty. And our builders don't really even know where it runs. They just have to go look at the UI if they care. Events are critical to both these flows and then the unification of data and machine learning. I think we've all been in systems where you have what I call dueling cron jobs. This runs at the data runs at 6 a.m. and we know it on average takes 48 minutes. So it goes ours run to 7 a.m. so that then the model trains, but then daylight savings time happens and then one system updates and the other doesn't, or maybe something fails and you're training on stale data. If you've been there and if you know, right? Oh yeah, exactly. So this is how we use events. Every flow emits events. The DBT and ML models then react to them. And then the next step is we trigger into the service platform team. When the machine learning model finishes training, we send another event. We then pick it up, have a Lambda, calls out to Circle CI, does some things. And then we're deploying the model, either the replacement model or possibly as a variant. You don't always want to deploy a new model. You want to run multiple in parallel. So examples of the code again, how this works. We first go and get the data. So here, this is an example where we go get some 3P data. We go get on a schedule. When this finishes, we kick off all the DAGs. All the data finishes. When all the data finishes, we then kick off the training model. The training model says, hey, is this a new model or is this a variant? Launches that to the deploy step. And then we have a step that we own, which is the actual deploy to production step that manages all the interactions for the deploy CI/CD pipeline. So for the last little talk, I've been talking a lot about the data warehouse, but I want to talk about moving outside of it because there's a world bigger than the data warehouse here, right? Data ingestion. There's lots of tools out there. They go and they get data from a source, Stripe payment balances, PagerDuty, Jira. You want to do analytics on Whipple models on them. You want to go get data from a third-party API you need to use to build your model. In our case, maybe FreightWaves data we use for pricing information, or CAB, which is the Central Analysis Bureau, I think, for carrier risk, crashes, carrier information. Most of the time, these are a completely different team. And again, when that data breaks, that is slow, there's a problem. Our data pipelines are now running with the wrong data. Our machine learning models are running with the wrong data. And that's not very cool. It turns out we can actually just pretty easily shift this into Metaflow. So, the first example I have is Green Screens is another wonderful partner of ours. They do real-time truck pricing data. So we can use that to start training a lot of our models. Again, this is simplified here, but in this sort of step, we go get a bunch of shipments we care about from the past. We then go out to the API, go figure out what the prices were in the past, write it back into Snowflake. Now our model can kick off and start running. It's a fairly simple behavior. And what we've been playing with recently for the past month is how we can actually make it very easy to use PyAirbyte for all the third-party systems where they have open source connectors. If you all don't know, Airbyte is a really awesome open source product. Its alternatives are, I think, Stitch and Fivetran and things like that. They're very low-code ways to say, give me data from Jira and then write it to this other place. They've been wonderful in the way they built their system is that all their connectors are just code. You don't have to run any infrastructure for them. This is perfect for Metaflow. So we built an Airbyte manager. Our builders put a little bit of code and say, hey, Airbyte. Actually, they're not calling Airbyte, it's just using the code itself. I want to go get data from Jira. Here's my configuration. Here's the team I want. Here's the stream I want. Then we can just go execute it for you. Again, the data is getting to the same place in Snowflake as it was before. But now because it's getting there in the same system, we can be reactive. We can understand when things break. And again, if you work on a data team, the amount of time you spend saying, why is my data not right? Why is this model not training well? You have to trace the world all the way upstream to find it is crucial. Which then leads me to talk about the last thing. Now, Metaflow is in the story here because we just use it to manage some repetitive jobs and tasks and things like that. But I think it's important to understand the end-to-end data to machine learning story. So logistics is like a really complex business. Our data is not very big, right? It moves pretty quickly, but like even for trucks on the fastest data, like every 5 minutes is probably good enough, with a few exceptions. But in trucking, I remember it was like the second week I was at Convoy, it was confusing. We had 6 different copies or versions of fuel price. I was like, why do we have 5 different versions of fuel price? And it turns out that they're all exactly correct in one very specific domain, and they're completely useless in some other domain. And we've had like 2 COEs when people mix the wrong one. Because when they're in the data warehouse again, they go use the one they think they're supposed to use, but they don't know where it comes from, and so they forget. So what we've been working on is taking this lineage, and there's a lot of tools for this, and extending outside of the data warehouse. So here's a version of the, these are the DAGs that all power the compliance and fraud risk work. Okay. What we're doing is we're using open metadata, pretty simple open source tool. It has a really great API. So listen, what can we do with this information? So at the very end here, I zoomed in, and these are like the final 3 tables. These are the ones that we use to either build models or power analytics. And then a whole mess of stuff there, which I'm going to zoom into in a minute, okay? What I want to show is that on the far left, we saw extending lineage outside of the data warehouse. You can see here now that we're getting this data from a third-party source. This one picture's a little outdated. I haven't labeled this yet. But you can say, hey, this comes from the cab thing. It comes from this Metaflow data integration. This is where you go get it. This is how you know where it comes from. And the other big thing we just sort of have to accept in this world is that most data is stolen from production systems databases, hopefully by letting the engineering teams know that we're stealing their data and breaking the first rule of like encapsulation, right? CDC is a thing. We'll never get rid of it. So we extend the lineage to the Kafka stream. In our case, we're using Redpanda. Then we scan from the Redpanda stream to the Postgres database. So now our builders, when they're saying, why is my data not working? They can click a link over here, and they can go chase it all the way upstream to all the different sources, to the production teams that they go talk to see what changed. This sounds small, it sounds simple, but it actually solves one of the hardest problems we have to face from my point of view, which is who owns this data, where did it come from, what does it mean? Finding that out is actually, just takes time. So streaming data is also foundational to our system. We have, like as I say, you know, we have to move at the speed of the business, not the data pipelines of the world. A year ago, a carrier pulls up, we give them a score on their trip. It's probably a really good score, but they don't find out till 12 hours later. And then sometimes it's a bad score, but we know it's a bad score already, right? Because we can see the production systems, they don't know it's a bad score yet. And then they can't book their next load. And like, what's going on with that? Using things like Redpanda, Rising Wave, Iceberg, we're moving a lot of that logic outside of the data warehouse. And this is a completely different talk we can talk about tonight or next year. But here, again, Metaflow is in the middle because we're using it to solve problems of data model drift. If we have when you think of streaming data, you still want the batch compute as well. There are times you want to change something, you want to do like a big back computer across everything, so you want to do it in Snowflake. You still need it. So with Metaflow, we can say, take this dbt model and apply it to Snowflake, then also make sure that the version that's applied in Rising Wave is the same. It is, again, just foundational to how we make the teams work together. And with that said, 1 minute left. Thank you all very much. Questions?